Hi there, Gregory Carlson here. Let's do part 3. So I hope you've had a chance to do this problem on your own before I do it. I'm going to go through this a little quickly. So first we need to find the derivative. So we take the limit as h approaches 0 of the following. Now, first we have f of x plus h. So this would be x plus h to the third. That's f of x plus h. Then minus f of x all over h. So I just applied the definition of the derivative that we've been using. I just didn't write it down this time. So let's simplify that a little bit. By the way, this is equal to f prime of x, our derivative. So let's simplify that. What you can do here is you can do x plus h times x plus h, FOIL that, and then times that by x plus h and FOIL again. And when you do that, you're going to get the following. X to the third plus 3x squared h plus 3h, plus 3xh squared plus h to the 3. So I'm sure you're wondering how I was able to do that without doing any work. And I was able to do it thanks to the binomial theorem. And so if you want to find out how to use that, I hope you'll keep taking math classes. So anyway, I'll explain that in another video maybe. So, and we still have minus x to the 3. And we're still over h. So there you go. I just FOILed that thing. And you'll notice that x to the 3 cancels with negative x to the 3. Now we need to get rid of this h down here so that we can evaluate the limit. So I notice luckily h goes into everything on the top. So let's factor out an h on the top, which will give us 3x squared plus 3xh plus h squared all over h. So I just factored out an h out of the top 3 terms there. So that h cancels with that h. So I get 3x squared. Oops, I'm sorry, I still have my limit. So that equals the limit as h approaches 0 of 3x squared plus 3xh plus h squared. So now let's go ahead and evaluate the limit. Now is when we do it, once we've gotten rid of that h in the denominator. So if h goes to 0, this term goes to 0, and this term goes to 0. So that means f prime of x, is our derivative, is equal to the function 3x squared. Okie dokie? Isn't that great? So the derivative of x to the 3 is 3x squared. How very curious. I hope you're not getting sick of me doing that. I'm trying to hint at what's coming next. All right, they want the equation of the tangent line through the point 2,8. So we use our point slope formula, big Y minus little y equals m times big X minus little x. Okay, so my point is 2, 8, so this is y minus 8 equals my slope times x minus 2. Now, let's calculate the slope. Our x value is 2, so if we find the derivative at 2, we see that the slope is going to be 2 squared is 4, 3 times 4 is 12, so our slope is pretty steep. It's equal to 12. Finally, just solve for y to get the equation of the line. So, and then just add the 8 over. Y equals 12x minus 16, it looks like. And there's the equation of the line they're looking for. Y equals mx plus b, y equals 12x minus 16. Really quick, here's what the graph of x cubed looks like. Right? So we have a point here, and so that's pretty steep. That's the point 2,8. It's a pretty steep positive tangent line that crosses through negative 16 as our y-intercept. So that's putting it all together with the graph. At this point, if you're getting the hang of this, feel free to skip ahead in the video. I feel an obligation to do all these problems for you, so I'm just going to keep going. The derivative of this, you might want to definitely check out the beginning of each problem if you get stuck. It's f of x plus h minus f of x, whoops, all over h. Maybe you're even working ahead of me. That would be good. So again, we're going to times this by x plus h, times this by x plus h, and times this by x over x. So, oh, I forgot my limit. There we go. So that's equal to the limit as h approaches 0 of, let's see, this is going to be x times x plus h on the bottom times 1 over h, because that's my h right there, times 1 over h. And on the top, I have 2x from here minus, so this is equal to 2x plus 2h. Do you agree with me? So that means it's when I distribute this negative sign, it's going to be minus 2x minus 2h. Okay? I skipped a few steps there, but I hope that makes sense. I did the distributive property with the negative 2, and so it would be negative 2x minus 2h. So 2x cancels with negative 2x. So this simplifies to the limit as h approaches 0 of negative 2h over x times x plus h. And now we have h cancels with h. I still have my limit. And now at the very end, as usual, it's time to evaluate it. So let's let h go to 0. So that goes to 0. And so we get the derivative is equal to negative 2 over x squared. That is the slope of our hyperbola everywhere. So let's find the tangent line at 6 1/3. It's big Y minus little y equals m times big X minus little x. And let's go. So we got y minus 1/3 equals. Now what's the slope if I plug in a 6 here? That's going to be 6 times 6, which is 36. And so negative 2 over 36 is negative 1/16 times x minus 6. So where did I get this negative 1 over 16 from? I just plugged in the number 6 and into the derivative function. So I got negative 2 over 36, which reduces to negative 1 over 16. So let's distribute that. We get y minus 1/3 equals negative x over 16 plus, let's see, that'll be 3 over 8, right? And then plus 1/3 plus 1/3. Y is equal to negative x over 16. And if I do 3/8 plus 1/3, that's going to be 9 over 24 plus 8 over 24. And so that'll be 17 over 24. So there we go. It is in slope-intercept form. We had to do a little bit of fraction work there at the end. Yeah, that's our equation of our tangent line. Negative x over 16 plus 17 over 24. That's the actual tangent line at the point 6 comma 1/3. Okay, I'm getting kind of tired of doing these now, so I'm going to cheat on this one. And I know a little trick on finding the derivative very easily of this. Okay, are you ready for me to cheat? I'm going to say that this negative 5 doesn't affect our derivative at all. And the derivative of negative 6x squared is going to be negative 12x. So if you're wondering how on earth I was able to calculate the derivative and do all of this work in one step, I will show you in about 3 videos. But this 2 multiplies, and so it makes it negative 12x, and the exponent gets knocked down by 1. So let's find the derivative. Let's find the line of the equation that goes through this point. Y minus y1 equals m times x minus x1. See, I'm over 10 minutes, so I'll try to hurry up. Plug in -5 for x, and we get that the slope will be -12 times -5, which will be 60. So I get y plus 155 equals, remember, because it's minus minus, so it turns into a positive, 60 times x minus minus -5, or just plus 5. Do the distributive property, and then subtract the 155. 300 minus 155 is 145. So there's the equation of the tangent line to this function, this negative upside down parabola at the point -5, -155. So again, you could have done this with the definition just like before, but I cheated a little bit right there because we've done x squared before, so I think you could figure it out on your own. I have 2 more problems to go, and I am going to do those the long way because they're a little different, and I want to show you how to do them. And so I will do those 2 problems in part 4, and I will see you there.